Hi guys, in the previous video we had seen how we can create a bar graph to depict the frequency distributions for a given set of discrete values. We also discussed that if the number of unique discrete values increases beyond the point that a bar graph can handle, we can make use of a histogram. As we discuss, a histogram shows frequency distributions of a given data set. It can be used to represent discrete as well as continuous data. But histogram comes with a limitation. It can show us the frequency distributions of the given data set, but it cannot show us the numbers involved in a given bin. It only shows the count of the numbers within a bin. So with this, let us move forward. So before we go ahead with creating our own program to generate buckets and frequency counts, let us recap what we discussed earlier. See here, the range is 1 to 10. There are 10 numbers. This bar graph can manage to show those numbers and their frequency distributions. Now, here we generated 1 to 20 unique numbers, and the number of numbers is 20, and range is 1 to 20. Here again, bar graph is showing each and every discrete value's frequency count. And of course, as we can observe, these graphs are thinner as compared to this one because this graph has to show 20 discrete values. Here, this graph is showing 50 discrete values. Hence, the bars are still thinner. Now here, again, 100 unique discrete values, and it has got further thinner because it has to accommodate 100 unique discrete values, and also it started struggling to show all these numbers in x-axis. Correct? Now see here, 200 x-axis is going crazy. It cannot show all the numbers, overlapping is taking place. And here we are generating 1000 unique values, discrete values, and we cannot make out any of this thick black color. It is happening because the overlapping over here has got more intense. Since we cannot read anything in x-axis, these bars make no sense at all. Okay, to get rid of this problem, we created histogram, right? So let us create some random numbers like 1 to maybe 11, and we will generate say 20 numbers. Okay, and then we will say please give us histogram, and bin will be 10. Done. Okay, so here we can afford to generate any number of unique values, right? 500 unique values, discrete values. So this is a histogram for all those 500 unique discrete values. But this time, what is the difference? The difference is this histogram is not representing each and every unique discrete values. It has grouped them into 10 different groups, and it is showing the frequency count of each and every group, depending on how many numbers are there in each and every group. That is, we can call it bin, we can call it bucket, we can call it group. Okay, so this is what frequency distribution uh, does in a histogram. As we discussed, look, it says that 4 to 52.7, there are three numbers. We want to know what are those three numbers. Histogram cannot tell. It is not capable of telling that. It only counts the frequency and shows the frequency through this y-axis. Now, if at all we want to verify as to whether within this range those counts are fine, what are those numbers? And are those number only three or more than that? We can write a small piece of code. What we can do? We will say, okay, x1 is equal to np sort x, and then we'll say counter is equal to 0, and then we'll say for I in x1, that means we are reading each and every number, and we will say if I greater than equal to 4 and I less than 52.7. If that be the case, increase the counter. So one number comes. If it is true, if that number falls within this condition, the counter will get increased. Else not, the second number will be read. Like that, we will read all 20 numbers. Okay? And then we'll see the count, what happens. Okay? So let us do this and say print counter, and we will say print value here. Value is nothing but I, correct? And let us give one space here like this. See, 3. And within 4 to 52.7, these are the numbers, and there are three such numbers. So count has been shown, and we are seeing what are those numbers which are making the count to 3. They are 4, 31, and 50. This information, the information about the numbers involved in each and every bin is not given by histogram. That we should remember. Okay, good. Let us generate another set of number, and this time we will write our own code to create buckets like this or bins like this, and we will count how many numbers are there in each and every bucket. So let us generate another set of number. We will say random rand int 1 to maybe we'll say 21, that is 1 to 20, that is the range. And how many numbers? Well, we can say what? Okay, let us keep it simple, 20 such numbers. Okay, and just see what happens. Okay, we have generated this number. We are not going to use the histogram of matplotlib. We will write our own code to generate the buckets as well as the frequency count for each and every bucket. So what we will do? We can use these lines. So what we have done here, just see, we will create 10 bins, and look, we have written buckets 1, buckets 2, buckets 3. These are three different ways of creating buckets. So let us discuss them one by one. It is already there, but let us discuss. np dot histogram underscore bin underscore edges x20. This is going to create 10 buckets for this data set, that is X. Created? Good. Now we will use this syntax and see whether it is going to create same buckets or not. It is absolutely same, correct? That means both are working fine. Then this is another way of creating buckets, and we will see how it is creating. So what we are doing, we are taking range minimum to maximum, okay, and this is range, and we are stepping by what? It will step will be decided by this. So let us see what step does. Step is nothing but 1.9, okay. Then we will start from minimum and go till maximum, and then just see this is what is done by these two lines. Has it created the same buckets? Yes, 1, 2.9, 4.8, 18.1 and 20, which means we can use any of these three lines, I mean three types of ways to create buckets. Okay, so it is already done there, so I'm just removing them so that we keep the notebook neat and clean. Let me remove. Okay, now we will run this, and just for confirmation we will take the output of all those variables. All of them should show us the same result, right? Look, here, all of them are same, which means we can use buckets 1 or 2 or 3, doesn't matter. Great. So first step of creating histogram is done, that is creation of buckets. Next is within this bucket how many numbers, within this bucket how many numbers, that we have to do. So we will bring up that code. So this has already been done. Okay, let me remove this also. This is not needed. It is anyway getting created here. We will simply use. Now what is this doing? This function. This function will give us frequency count for each and every bin, or each and every bucket, or each and every group. So what we will do? Simply invoke this function, get frec, and what we will pass? This x we will be passing. And then we will pass the buckets created over here. So let us use any one of these variables. So let me use buckets 1, and then it will give us the count for each and every bucket, right? So we have seen two things, buckets and the count. Now for confirmation that our code is working fine, let us use the inbuilt histogram that is supplied by matplotlib. We will say X and then we will say 10, right? For 10 bins. Look, our buckets 1, 2.9, 1, 2.9, 4.8, 4.8, 6.7, 6.7. Like that it goes 18.1, 18.1, 20, 20. So our bucket creation is perfect. And what about frequency count? Okay, matplotlib says 1, 2, 3, and we say 1, 2, 3. Then 2, 3, 1, 2, 3, 1. Then 2, 2, 2, 2, 2, 2, 2, 2, 2, 4 twos. Correct? So it is matching, which means our code is working for counting the frequency. And bucket creation is also correct, right? So this is how we can create buckets and frequency count. But do we really need our program to do this? No, there is no need to reinvent the wheel. We already have matplotlib supplying us histogram. This one piece of line does that for us. Thanks for watching, and I will see you in the next video.